So, First of all, let me introduce myself. Well, hi, I am a UX designer. I'm here working to give the best end-to-end user experiences. I like creativity, innovation, games, music, and of course, having good experiences. I've joined Avenue Code in September 21, almost a year ago, and I currently work with our client Gerdau. And today, as Carmen said, I will be talking about good usability practice to design interface, starring the 10 usability heuristics created by Jacob Nielsen. And all of you use and see these heuristics every day in many interactions that we do every day. We will talk about each one later, but first let me talk a little about design. When I talk about design, our goal is to make things happen naturally, without requiring an effort to understand or perform an action on a system. That's why a good design is the one that you don't even notice. Is when you perform a task with the least possible effort, intuitively. The heuristics that we will talk about in these presentations are like patterns to help us to create a good design. So what happens when we don't follow those good practices? Well, when you face a bad design, you know that you are facing a bad design. And sometimes you can blame yourself for not understanding how to do something or what's the meaning of each action or button. But in fact, that's a bad design fault. Sometimes it may get confusing and you need to think more or pay 10 times more attention to final and do your task. Or you need to read a lot of instructions. And sometimes bad design can lead you to an error. Like imagining that your interaction with a system can put lives in risk. Let's watch this video.
15 seconds to core meltdown.
Eeny, meeny, miny, mo. Take it, tiger by the toe. If he hollered, let him go. Eeny, meeny, miny, mo.
And yes, a good design can help to prevent errors and also save lives.
15 seconds to core meltdown.
Eeny.
In addition to interfaces, bad designs can cause confusion in any other context. It's very important that the patterns we already understand, the heuristics, are always applied to facilitate our interaction and comprehension of the world. We face design in everything, everyday things. Jokes apart, let's talk now about the heuristics. First of all, what is a heuristic? Let's start from this word. The heuristic comes from a Greek word called eureka, which is a word meaning found or discovered. It is usually spoken by someone who has just found a solution to a difficult problem. It's like I've tested something and from my experience, I know what worked and what didn't. So I reported this as a heuristic. The 10 usability heuristics was proposed by Jacob Nielsen, one of the greatest usability researchers. He proposed them to create more intuitive interfaces in the 90s, and we're still talking about them today. So now let's dive into each one of them. The first one is visibility of system status. This first heuristic tells us that the user must be fully informed of what is happening through the immediate feedback from the interface. So everything the user does or interacts with the interface, they should receive an immediate response from the system to them. And preferably that doesn't make the user think. That is a clear and direct message about the interaction between human and computer, for the user to identify and understand immediately what's going on. Imagine a form where you fill a field incorrectly and try to proceed. Immediately, the system returns a feedback highlighting the field I filled in incorrectly and informing me what the error is. Like in this case, that the user tried to fill in with an invalid email, and immediately the interface returns a feedback to the user, giving visibility of system status. Another example about this is when you are going to upload a file and a progress bar appears, showing how much has been completed and how much remains to be done. Like here, I am uploading a file and it gives me the visibility of system status. That is how much has been completed and how much remains to be done. Also, those icons that we face every day, like the Wi-Fi, battery, Bluetooth, and many others, they give you visibility of system status. They tell us what is going on. These feedbacks can come in many different ways. The important thing is that the user understand what is happening from the interaction he had just made with the interface. We can't let the user interact with our interface and show no results. Otherwise, they will be very likely that the user think that nothing happened and will repeat the action. So if you interact with something, it might give you a response, like pressing a button in an elevator, then the button light turns on. Okay, let's move to heuristic number 2, that is match between system and real world. That means that the system should speak the user's language with words, terms, icons, things that matches with our users' mental models. Remember, the design is made for them and not for you. The mental model refers to the user expectation of something. We can't just use extremely technical terms because only people from that specific context will be able to use that system fluidly. Other users, you have difficulty. If I'm creating a system where the users are engineers, for example, I can use that user's technical terms. But if some other type of user is going to use the same system, they will have a hard time understanding because they are not familiar with the terms. The system doesn't speak the user's language. The compatibility between system and real world can also be noticed when I use elements from the real world or something that our user already has a well-formed mental model. We have created a pattern about that in our minds and the function they performs. And this helps us to perception about the perception of the system compared to real life. A classic example of this is the floppy disk icon to illustrate the action of saving some file. As many of you know, in the past we used it to save our files in floppy disks, and that was the basis to represent the save action with an icon. Users have this mental model that floppy disks was used to save files. Then when it came to interface, it represents well this action. And that matches between the system and the real world. In a different context, like this boarding pass, there is another good example of how the figure of a real element, the airplane here, was used to guide the user to find his seat. So here, the user is looking for the seat A22, and the figures show an illustrator of the real-world plane where he enters and where he sits. So users will know that he enters here, and the seat that you'll find is near right after the wing. This way, our design is matching between system and real world. Okay, heuristic number 3, that is user control and freedom. Users constantly perform actions by mistake and or unintentionally. And we need to give the freedom to these actions to be undone during their interaction with the system they are using. According to this heuristic, we need to provide emergency exits to our users so that they can undo or redo their actions. This way, we are giving user control and freedom. The Control Z is the most obvious example. If I have a system with a lot of destructive actions, I will be very careful when I'm using it. But if the same system gives me control and freedom, I feel much more comfortable using it. Because I know that if I do something wrong, I have the control to undo it. In Photoshop, for example, in addition to Control Z, available to undo the actions, we have a history that allows the user to view all their actions and undo them. We have another classic examples like the recycle bin, the trash, which allow us to recover deleted files. This is all about giving control and freedom to the user, giving the user an emergency exits for errors or unwanted or unexpected actions. The heuristic number 4 is consistency and standards. Speak the same language all the time. Never identify the same action with a different icon or metaphors. This heuristic says that similar elements must be used for similar purpose. Just as similar functionality must have a sequence of similar actions. We need to maintain the standard of colors, elements, alignment, contrast. Everything that makes up our system must have a consistency from the beginning of the interaction to the end. We can see in those images that there is a pattern about it, and we should follow it when designing an interface. Like here, the position of the logo in a website and its function. Like here in Google, Microsoft, YouTube, and many other sites. There are many standards beside this one, and we must be very careful when trying to innovate something that is not consistent with the standards that are already adopted by users. Otherwise, they will probably get it wrong. Like in this data, the percent of users who wanted to go to the homepage and miss it is 20% higher when the logo was in the center. This happens because users are familiar with the logo in the left corner, and by clicking it, they are redirected to the homepage. This is a mental model already built in and common in our interfaces, in the interface we use every day. So be careful in trying to innovate something. Heuristic number 5 is about error prevention. Good error messages are important, but the best designs carefully prevent problems from occurring. So ideally, the interface should be able to anticipate the errors. We need to assume that the user will make a mistake, and then the designer needs to create a solution that prevents this error before it happens. A simple example of this is when a button is disabled until you execute the correct function to enable it. Or when you need to select a date in a booking system, for example, and the days that have already passed are disabled. So the user are not allowed to do the wrong thing, and this way the design is preventing an error. Heuristic number 6, recognition rather than recall. The user should not need to memorize what he's doing because our short-term memory is limited. So the interaction needs to be direct and dialogue with the user all the times. Information needed to use the interface, like labels, for example, should be visible or easily retrieved when needed. Allow the interface to talk with the user while he performs his task. Some of examples of this is autocomplete. When we access a website and next time we go to it and you start typing the link, the system automatically autocompletes it for us, reducing the effort of having to remember what was the link. The search histories, which save us from the effort of remembering what we was looking for recently. We also have histories in our bank apps, for example, that save contacts that we already have transferred money, and in our phone contacts, numbers, etc. These are examples that allow us to recognize rather than remember, reducing our cognitive effort and giving us a better user experience. Heuristic number 7, we are almost finishing. That is one about flexibility and efficiency of use. I may be an experienced user, but the application is not made for experienced users only. The system must be simple enough for non-experienced users, but it must provide shortcuts to speed up the actions for advanced users. A clear example of this are the shortcuts we have in a system, such as the classic key Ctrl-C and Ctrl-V. for users, this is automatic, and we should make these shortcuts available to provide a smoother and faster experience. However, users who do not know the shortcuts can also browse and use all the features using the options that the system makes available. This example of Figma shows, in addition to the function, which is the shortcut to execute it, teaching more advanced users to use the tool and non-experienced users too. Some shortcuts are even patterns built in our mind, and we shouldn't change them. Imagine, for example, that we are going to use a tool or a system which Ctrl-C that we just saw, Ctrl-C and Ctrl-V, doesn't correspond to what we expect, which is copy and paste. We will probably feel like this guy in this video. Like here, he's trying to turn this on, and then the light turns on. And it gets very confusing. Okay, heuristic number 8 is about aesthetic and minimalistic design. Less is more. Each extra information in an interface competes with the relevant information and decreases their visibility. Users have a job to do when using an interface. We should not put information that doesn't correspond to their task, to the task they want to perform. Otherwise, they will be a distraction. So do not pollute your interface with too many things or make your interface lacking in information. Look at this example. The job to be done here is simply to log in only. And the only prominent information we have here is what leads the users to complete the task. When we give a lot of information to the user, he gets lost and takes time to understand what the system wants him to do. Also, the colors, they are simple, they don't steal the user's attention and makes it simple, beautiful, and useful. Like this game interface, I guess it's from League of Legends, right? But it's simple. It shows even from non-users or players, what we have to do. And at this moment, apparently we need to level up some spell. And now look at this interface. It's too much information, right? I don't play any of those games, but I can tell that this one is way harder to understand what's going on. Okay, heuristic number 9 is about help users recognize, diagnose, and recover from errors. As we have already mentioned, the design must prevent errors, but the error is not always a consequence of users' actions. When these errors happen, we must clearly inform what is happening and guide our user on how to proceed. And we never should display error message with the source code alone. This is an example from the website Clorox, a cleaning products company. When we face it with a non-existent page, the famous 404, the page informs us what happened and gives the user options to continue browsing, like here, go to home or go to all products. Another option in this same context, as on the Avenue Code site, is to provide an internal search field on the site, helping the user find what he is looking for. Well, the last one is about help and documentation. We saw that good design saves the user from having to use help options frequently. However, it's essential that the system has a help and guidance area in case of doubts. This can be done with a guided access, some places with videos or animations of how to execute some functionality, or else help in specific places like tooltips. Here we have a good example in FigJam, which uses guided access to guide new users and also provide all help material, tutorial, and user support. And well, these are the 10 nuisance usability heuristics, and they can be applied at any time in the product. That's about design, guys, and trust the design. A good design can improve anything. You can reach us anytime. If you like this topic, here are some reference to know more about design. These two books are very easy and cool to read, and the NNG, Nielsen Norman Group, have a lot of articles, which the 10 usability heuristics are one of them. And that's all, folks. Thank you all for listening. So now I'll be open for any question.
Gustavo, thank you so much for the presentation and for sharing your knowledge. It was an amazing subject, and I'm sure we learned a lot today. And so I believe we still have a few minutes, guys, so feel free to ask any questions if you have any. So please go ahead, Holly.
Holly?
Hey, Gustavo, question for you. I think the thing that I loved about this talk is that these are all very common sense and intuitive heuristics when you think about it, but we still see them overlooked again and again. I'm curious, in your experience working in products, what do you see as the most overlooked? What's an easy win that any designer, developer, product owner could just keep in mind? And, I guess the question is like, what's the most common error that you see or common violation of this?
Well, some common violation of this I see very often is error prevention. A lot of system leads the design to an error, like display some button that shouldn't be there. And also the visibility of system status. I see this a lot also in interface and in the real world. We interact with a lot of things that doesn't give us feedback about what is happening. So we don't know if it already done or it didn't make nothing. We just wait for something to happen by our interaction. I guess those are the most commons that I see almost every day. That is visibility of system status and error prevention.
And it's so funny because the visibility of system status, it feels just like in a conversation. Like if you say something, you want to know that the other person heard you.
Sure,
You're not
exactly.
just talking into a brick wall. It's like basic psychology,
Yeah.
Cool. Thank you.